project, we have learned how to filter, and in particular, how to blur images using an algorithm called discrete convolution. First of all, we have learned that images are represented by matrices. In particular, each pixel in grayscale corresponds to an entry of a matrix, and its value is in the range 0 to 155. In both languages, Python and MATLAB, we have imported images and converted them into grayscale using methods and functions. In Python, matrices can be stored as two-dimensional NumPy array, which are accessed using square brackets with indices that start from 0. While in MATLAB, matrices are accessed with round brackets and indices start from 1. To implement the operation called convolution, we have used nested loops to cycle over the rows and the columns of the image and the kernel. The syntax is similar in the two languages. But while in MATLAB a for loop is closed by an AND, in Python we have to carefully use indentation. By repeating local convolution over each internal pixel, we have obtained a blur image, which, however, is smaller than the original one. To circumvent this problem, we have performed padding on the original image before filtering. To add black pixel, we can simply create a matrix that is larger than the original and copy the original image in its internal rows and columns. To consider rows from the second to last, in Python, we use 1 : -1. While in MATLAB, we go from 2 to n-1. Using padding, we can obtain a filter image which has the same size as the original. And now it's your turn. Try to load a larger image, for example, the entire car plate, convert it in grayscale, and try to apply blurring. Can you still read the numbers? If so, write a code that repeats the blurring process many times. Another option for blurring is to use larger kernels, like this one, which is 5 by 5. Try to modify your code to use a larger kernel and pay attention to padding. Is the blurring more pronounced now? And finally, using convolution, we can do so much more than just blurring. Try to apply, for instance, this kernel or this one and see what happens to the image.